So this video is about, I'm just going to go through some worked examples of Pythagoras' theorem and trigonometry. They both relate to right-angled triangles, finding side lengths with Pythagoras, and with trigonometry we can find side lengths and angles, and you'll get these embedded within some exam questions for Unit 661. So you need to watch the other videos first where I explain the theory, but I'll just start off with, what you really need to know to be able to do these questions. So we've got a triangle on the left here, a right angle triangle because it has the little square that shows it's a right angle, and opposite, well, I should say really across from, to not cause any confusion, but it is opposite the right angle is the hypotenuse, which is the longest side. So the longest side is always across from the right angle. And if you remember from the videos and links that I've shared, the longest side squared is equal to one of the short sides lengths squared plus the other short side length squared. Sometimes it's easier to remember it with words than letters. So we could say the longest side squared is equal to one of the short sides lengths squared, which means times itself, added to the other short side length squared. So you can remember it with words or with letters. Just need to remember that in these formulae that we're going to use, that C is always the hypotenuse. So C is reserved for the hypotenuse, and A and B are just the other two sides, which are always going to be shorter because the hypotenuse is the longest one. So it doesn't matter whether I wrote B here instead of A or A here instead of B. The only one that's really important, the letter, is C for the longest side or the hypotenuse. So from this, if we want to find out the longest side, as in the other video that I've shared, the longest side, when we square root both sides, is one of the short sides squared plus the other short side length squared. So in your calculator, I'll show you how to do these, and it's quite simple, believe it or not. It's quite simple to put the numbers into the calculator, and I'll show you how to do it, so don't worry about Pythagoras. So if we want to find, say, the short side A, find its length, then to get the A term on its own, we need to move the B term to the other side, like we've done in rearranging formulae. So we'd take the B squared, move it over, change the side and change the sign. So what we'd be left with would be A squared is equal to C squared minus B squared. And similarly, if we wanted to find what B was, well, we've got the B squared term, so we would move the A squared term to the other side and it would become B squared is C squared minus A squared. But we don't want to find the squares of our answers, we want to find the actual answers themselves. So if we square root both sides, we end up with the shorter side length is the square root of the longest side squared, take away the other short side squared. And the same for B. The length of B, which is this side, if we choose this one to be B, is equal to the square root of the hypotenuse squared, the longest side squared, take away the other side, the other short side squared. So the three equations to really remember is this one here to find the hypotenuse, this one here to find one short side, and this one here to find the other short side. That's all you need to do. And because the hypotenuse is the longest one, when we're finding the hypotenuse, C, we use addition, because addition gives us something that's bigger, doesn't it? But if we're finding a shorter side compared to a longer one, we're going to have a subtraction. So it's important to remember, and it's mentioned in one of the videos, but if we're finding the longest side, there's going to be a plus sign here. But if we're finding one of the shorter sides, it'll always start with the hypotenuse squared, and there'll be a subtraction sign. Same for the other shorter side. Got the hypotenuse squared and a subtraction sign. So take this first example of Pythagoras' theorem. We've got a right angle triangle, because we can only do this with right angle triangles, otherwise Pythagoras doesn't work. We've got one short side of 10, another short side of 6 units. Doesn't matter whether it's miles, meters, centimeters, inches, millimeters. We don't care. It's just 10 units of whatever the unit is and 6 units. And we want to find the hypotenuse. And how do we know it's the hypotenuse? Well, because it's facing the right angle. And the hypotenuse, or the longest side, always faces the right angle. So because we're finding the largest side, we're going to use this equation 1 up here. So the length of the hypotenuse is equal to the square root of the other two sides squared and then added together. So it's going to be the square root of 10 squared added to 6 squared. So on our calculator, we can put in square root of 10 squared added to 6 squared. These are the buttons that are pressed, and then press equals, and then it gives you an answer in what they call surd form, which is an exact answer, but it looks a bit alien to us. So to change from what we call surd form into a decimal number, you press this SD button, which means surd to decimal. So we want to go from surd to decimal. So press SD, and there we go. The hypotenuse is 11.66 units long to 2 decimal places, because after the 2 sixes there's a 1 which rounds down. So the answer of the hypotenuse here is 11.66 units. And that's that. So that's finding the hypotenuse when we know the other two side lengths. You need to know 2 side lengths, and they would never ask you to find, they'd never ask you to use Pythagoras if you only knew 1 side, because you can't do it. So the next example, we're also finding the hypotenuse in this one because it's the unknown side and it is the longest side, and we know that it's definitely the hypotenuse because if we draw a line through the right angle, that's the one that it's facing. So to find the hypotenuse, the length of the hypotenuse is the square root of the other 2 sides squared and added together. So 4 squared plus 3 squared. And of course, some of them you can do in your head. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is 5. But you're not expected to do them in your head. So I will just clear this off. Let's do the next one. So we can do it on a scientific calculator in one go, in one step, without having to write anything down. So the square root of 4, and to get 4 squared, there's a little x squared button on your calculator. So that means whatever I just typed, whichever number I put, when I press the x squared button, it squares it. So 4 squared plus 3 squared, and then it gives us the square root of that, so the answer is 5 units. So the hypotenuse is 5 units long. And that's what we expected from when we did this one in our head. So C equals 5 units of length, no matter what the units are. So that's finding the hypotenuse using the addition formula. Now we'll do some where we find a shorter side. So now we're going to find a short side length, and one way of writing the equation from earlier was say this, we could call this side B if we want. We don't care whether we put B or A, they're interchangeable, but the only one that isn't interchangeable is the hypotenuse C, and we identify it by pointing through the right angle, and there it is. So we know the hypotenuse, or the longest side, and we know one of the shorter sides. So what we would say here, we want to find side A, which we could have called side B, but you have to call it something. So A is the square root of C squared minus B squared. But an easier way for me to think of it is a short side is equal to the square root of the longest side squared, take away the other short side squared. So the other short side that we're after, A, is equal to the square root of the longest squared, so that's 50 squared, take away the other short side squared that we know. So 50 squared, take away 40 squared. And then we get our calculator up. So we put the square root sign of 50 squared, take away, and we always use take away when we're finding a short side. And when we're finding a short side, we always start with the square of the longest one. So square root of 50 squared minus 40 squared is 30. So the length of the unknown side is 30 units. It'll have the same units as all the other sides. That wasn't too bad, was it? So in this example, we've got a right angle triangle that looks a little unusual. It's wonky, but we know it's a right angle triangle because it's got this little right angle sign in it. And if we want to figure out which is the hypotenuse, draw through the right angle. And it's this one that's 100 centimeters long. So we know the longest side, and we know one of the shorter sides. This one's 20 centimeters, the hypotenuse is 100 centimeters. So the one that we don't know is this one. And because we're finding a shorter side, we use the formula. A short side is equal to square root of the longest squared, and we know the longest is 100, take away the other short side squared. So we're doing the square root of 100 squared, take away 20 squared. Get the calculator up, press square root of 100 squared, take away 20 squared. And that gives us an answer. Calculators often give us the surd form unless you set them up differently, but all you need to do is press SD. So the other side is 97.979 centimeters long, but we're going to round it to 2 decimal places. So we've got a 9 and a 7, but there's a 9 after the 7, which rounds it to 97.98 units long. And because we're told the units, we would put the units in. So the unknown side is 97.98 centimeters long, because that's what our calculator told us. So now we're on a trigonometry worked examples. You must watch the video on this before you attempt these, otherwise it'll make no sense. We're going to find side lengths or angles in a right angle triangle. That's what trigonometry is for. So we've got a right angled triangle here. I've called it trig 1, so that's the number of the question, if you like. So we've got right angled triangle, a side is 9 units long, an angle is identified as 40 degrees, and we've got an unknown side. So we want to find the length of the unknown side, but we need to figure out which sides are of interest. So remember, with the sine function, the sides of interest are the opposite and hypotenuse. With cos, it's adjacent and hypotenuse, and with tan, it's opposite and adjacent. And opposite and adjacent depends on where the angle is. So this is our angle, so the opposite side, the one opposite to the angle, is here. The side next to the angle, as in right next to it, is here. So this is the adjacent side, and it's worth 9. So in this question, the only sides of interest are the adjacent 9 and where the question mark is, which is the hypotenuse, because it's the longest side. And remember, the hypotenuse always is facing the right angle corner. So we've got an adjacent. Cos and tan have adjacent in them, but we've got hypotenuse as well, which is of interest. So we've got hypotenuse there. Tan doesn't have hypotenuse in it. So the only function that has both of the sides that we're interested in, as in the adjacent, which we're told is 9, and the unknown, adjacent and hypotenuse, is the cos function. So we know this is a cos or a cosine question. So all we can say is the cosine of 40 degrees, which is a known number. We know what it is because a calculator will tell us what it is. Cosine of an angle is equal to the adjacent side length divided by the hypotenuse side length. But we know the adjacent is worth 9 units, so that's equal to 9 divided by the hypotenuse, which is the one that we don't know. So the only thing we don't know, because we know what the cos of 40 degrees is because the calculator tells us, we know what 9 is because it's 9, the only thing we don't know is this question mark. So to get the question mark on its own, we've done rearranging equations. I'll write it out again. Cos of 40 degrees is 9 over question mark. To get the question mark on its own, we slide and rise like we did in rearranging formulae, and then swap and drop the cosine of 40. And what we end up with is the unknown side, the hypotenuse, is equal to 9 divided by the cosine of 40 degrees. Make sure that your calculator is in degrees mode, otherwise you won't get the right answer. So let's do this. 9 divided by the cosine of 40 degrees. So our calculator, to figure out, like my calculator is in degrees mode, but if it wasn't, on this calculator I do shift setup and then number 2 for angle input or angle unit, and I want it in degrees, so I press 1. So I press shift menu 2 and 1, and on this calculator that gives me degrees. But we need to work out 9 divided by the cosine of 40. So do 9 divided by cos 40, close the bracket, press equals 11.748. So round into 2 decimal places, the 7 and the 4, but the 8 will bring the 4 up. So it's actually 11.75 to 2 decimal places. So the hypotenuse is 11.75 units long to 2 decimal places. That wasn't too bad. The calculator did all the work. We just need to remember how to rearrange the sine, cos and tan functions to get the side that we want. and that's explained in the video that I made that's about 20 odd minutes long. So we know now that this unknown side, the hypotenuse is 11.75 units, the same units as all the others. If this was 9 centimeters, that'd be 11.75 centimeters. So with practice, you'll find these are actually quite easy. So trig 2 example 2 for trigonometry, got a right angled triangle, you've got a 30-degree angle, you've got a side, and we've got a hypotenuse. We want to find out the hypotenuse. So what are the sides of interest? So you write SOHCAHTOA. We've got we're interested in the hypotenuse. So sine and cos have the hypotenuse. We have the opposite, because 10 is opposite the angle. So we know the opposite side is 10. So we've got the opposite there, and tan has the opposite. But the only function that has both of our interested sides, opposite and hypotenuse, is sine. So this is a sine question. So what we can say is the sine of 30 degrees equals the opposite side divided by the hypotenuse, or sine of 30 degrees equals 10 units, because we know what that is, because we're told it, 10 divided by the length of the hypotenuse. So to find the unknown, the hypotenuse, you slide and rise the hypotenuse to the left hand side, swap and drop the sine of 30 degrees to the right hand side, and what we end up with, the hypotenuse, or the unknown side, is 10 divided by the sine of 30 degrees. And we know what the sine of 30 degrees is. It's a known number because our calculator will tell us what it is. So let's do that. We're doing 10 divided by the sine of 30 degrees. So 10 divided by sine of 30, when my calculator is in degrees mode, is 20. So the hypotenuse is 20 units long. So now we know, and we can write it on. If this was in miles, then that would be in miles as well. If this was in millimeters, then that would be 20 millimeters. So that wasn't too bad, but it does take practice. So for trig example 3, we've got the same triangle as last time in trig example 2, but instead of finding the hypotenuse, we want to find the adjacent side now, because the hypotenuse is the longest one. The 10 is opposite, because it's opposite the angle, and the unknown is next to the angle, or adjacent to the angle. So I'd always recommend doing so, ka, and then toa, and then tick in which sides you know or want to know. We know the opposite, so I can put a tick under O there, I can put a tick under O there. We want to know the adjacent, so I put a tick under adjacent and a tick under that adjacent. And the only trig function that deals with opposite and adjacent is tan. So this is a tan question. So what we can say is the tangent, or tan, of 30 degrees equals the opposite length over the adjacent length. Tan of 30 is opposite. We know the opposite is 10 units divided by the unknown adjacent. So we want to know what the adjacent is. That's the only thing that we don't have a value for, because tan 30 is a known number, 10 is a known number, but the adjacent side, we don't know what it is. So slide and rise the adjacent to the left, swap and drop tan of 30 to the right underneath. We end up with the unknown adjacent side is 10 divided by the tangent, or tan of 30 degrees. Use our calculator. So 10 divided by, press tan, put in the 30, close the bracket, and the answer, when we press SD, is 17.32 units. Now we can write that on. So it wasn't too bad, but it does take a bit of practice. I think the hardest thing is rearranging the sine, tan or cos equations to get the unknown that you want as a subject. But we've done rearranging equations as one of our lessons. So now we're going to use trigonometry to find an angle, whereas up till now we've found side lengths, but I'd say it's possibly easier. It's certainly not any harder. So we've got a right angle triangle here. We've got the angle identified, so we can label the sides. We know that this is the hypotenuse side because it's the longest one and it's facing the right angle. We know this is the adjacent side because it's next to the angle, so this one must be the opposite side. So as ever, figure out which trig function it is. Is it sine? Is it cos? Or is it tan? So which sides do we know or want to know? Well, we know the hypotenuse, so tick the hypotenuse. We know the adjacent, so tick adjacent. The only trig function that has the hypotenuse and the adjacent is the cosine or cos. So what we can say, if you've watched the video, it explains why this is, but the unknown angle is equal to, because it's a cos question, it's going to be cos to the minus 1, which means inverse cos. It's also known as arc cos or shift cos on the calculator. Cos to the minus 1 of the adjacent side length divided by the hypotenuse side length. We know the adjacent, we know the hypotenuse, so therefore we can find out this missing angle. So the unknown angle is cos to the minus 1 of the adjacent, which is 9 meters. You don't have to write units in, of course, in a calculator, but we're just saying what the units are. 9 meters divided by 11.7487 meters. So get the calculator up, make sure it's in degrees mode. To do cos to the minus 1 or inverse cos, you do shift cos, and we do 9 divided by 11.7487, close a bracket, press equals, 40 degrees. So this answer is 40 degrees. So this unknown angle is 40 degrees. And that's that. Now we've got another example, call it trig 5. Got a right angle triangle. We know the hypotenuse and we know the opposite side, because 10 is opposite the angle and 20, the hypotenuse, is facing the right angle. So we know that's the hypotenuse. So as ever, we're going to find the missing angle, but we're going to identify which trig function it is. We know the hypotenuse, so tick hypotenuse. We know the opposite, so tick opposite. So this is clearly a sine question, because only sine has the opposite and the hypotenuse. So the unknown angle, you might sometimes see it written as theta, is sine to the minus 1 of opposite over hypotenuse. So we can write theta, the angle, is equal to the sine to the minus 1 of 10 centimeters divided by 20 centimeters. And then the calculator will tell us what the angle is. So we're doing sine to the minus 1 of 10 divided by 20. So you do shift sine 10 divided by 20, close bracket, equals 30 degrees. So our angle is 30 degrees. So if we had space, we could label it inside here, but we've said what it is. So finally we've got trig. Example 6, got a right angle triangle, so we can use trig. If it wasn't a right angle triangle, then we can't do it using this method. So we've got a right angle triangle, unknown angle, we've got a side and another side. So let's figure out what type of question it is to find this angle. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. 10 is opposite the question mark, so 10 is the opposite. 17.32 is next to or adjacent to the question mark, so this is the adjacent length. So we know the opposite, so tick opposite. We know the adjacent, so tick adjacent. And the only trig function with both the opposite and the adjacent is the tan function. So what we can say here is the unknown angle, which you can call it theta if you want, is tan to the minus 1 of the opposite divided by the adjacent. So we can say the angle is tan to the minus 1 of 10 units divided by 17.32 units. You do shift tan to get inverse tan. We always need to do an inverse trig function to find an angle. Tan to the minus 1 of 10 divided by 17.32, close the bracket, 30 degrees. So our angle is 30 degrees. And it's actually the same triangle as in one of our previous questions. We were just interested in different sides. So hopefully they've been useful to you. And just remember that when you're finding lengths using trigonometry, you'll be given the angle, so you use the normal sine, cos or tan. But when you're finding an angle, you use inverse sine or inverse cos or inverse tan. And a little trick for when we're finding lengths using trig, when we're given an angle and we're trying to find a length, once you've identified which of the trig functions it is, whether it's sine, cos or tan, which you can find out by figuring out what lengths you're interested in, then if it was a sine question and you want to find out the hypotenuse, then cover up the hypotenuse, and the hypotenuse is the opposite, because it's on top, divided by sine of your angle, which is on the bottom. If you wanted to find out the opposite side, then because sine theta and hypotenuse are next to each other in this triangle, you multiply them. So the opposite would be the sine of theta times the hypotenuse. If it's a cos question and you want to find the adjacent, then the adjacent, because it's on top, equals the cos of the angle times the hypotenuse, because they're next to each other. If you wanted to find the hypotenuse, it's adjacent on top divided by the cos of the angle. And if it's a tan question, if you're trying to find the adjacent, say, then the adjacent down here is the opposite divided by tan of the angle. And lastly, if you want to find the opposite side, the opposite is tan of the angle times the adjacent. So whichever one you want to find, cover it up. So if I wanted to find, if it was a sine question and I want to find the hypotenuse, cover up the hypotenuse, and all that's left is opposite divided by sine. If I wanted to find the opposite side, cover up the opposite and it's the sine of the angle times the hypotenuse. So these triangles come in handy. Feel free to write them down. So thanks for watching the video, and let me know if you have any questions, and good luck.